Hey guys, welcome to your fourth 9 weeks of science, the online version. So along with this video lesson we're about to get into today, you have the same PowerPoint examples and notes linked to Google Classroom for you. That way you have access to them outside of this video. But in that PowerPoint, there's also something pretty important that I'd like you to pay attention to. So the very first slide that you see is a suggested learning timeline. It gives you what you should be able to do by the end of this week. So you have your learning objectives, and our first lesson is all about energy. A little refresher on topics you've heard before, like kinetic and potential energy. Some new forms of energy are going to be appearing, as well as some pendulum action and some law of conservation of energy right back at us. But it also gives you a suggested breakdown of what you should be attempting to do each day. So in a very short version, on Mondays and Wednesdays of each week, you're going to want to log into Google Classroom and you're going to want to watch the new video lessons that are posted. They give you new information that's going to help you with your assignments for the week. On Tuesdays, Thursdays, and Fridays, there is no new lesson, but you should be working on your assignments. And from 1 to 2 p.m., I will have a link to a Zoom live video chat. You can use this if you need a little reteaching, if you need some homework help, or if you have questions that need answered. I will be on live with you on those days. By Friday of each week, you should have your weekly assignments ready to be turned in on Google Classroom. So at the bottom of that learning timeline, you see a list of the assignments that are going to be due by 3 p.m. on Friday, and we are turning those assignments in on Classroom. Not sharing them, not emailing them, but you know there's that special little button for turn in. Alrighty, so now let's go ahead and get into it. Our topic is energy, and keeping it short and sweet, energy is the ability to do work. So we talked about this a little bit with ecology. If an organism is going to be able to do its life processes, maybe it's photosynthesis, cellular respiration, maybe it's hunting or performing the role of its niche, it needs to have energy stored in order to do the work. Well, we are not looking with living organisms specifically this time. This could be an object. But if any object is going to be able to do work, it needs some stored energy, and it could be in any one of these forms. So let's take a look here. The first form of energy is what we call mechanical energy. Mechanical energy is what happens when an object is in motion. So motion is key here. So if it's lifting, pulling, twisting, turning, rolling, we say it has mechanical energy. So think about pedaling a bike, or the wheels of the bike rolling, the blades of a wind turbine, a hammer falling on a nail. These would all have mechanical energy. Next is light energy, or radiant energy, you may hear it called. Light from the sun, light from a light bulb, light from your computer screen. And light energy travels on that electromagnetic wave in most cases, and a wave is in motion. So we have a moving element bringing light from its object to your eye. Electrical energy. Again, we're starting to see a theme here, a little pattern. Electrical energy also travels on a wave, but this wave is going to be a wave that we call a current. And this current is moving electrons. Yeah, electrons. They're what swim around the nucleus of the atom here. And we can see electron currents traveling between these two conductors like I just circled. Lightning is a great example of an electrical current. And when you plug in your phone charger so that you have battery life for the day, you are inviting an electrical current to travel through the wire and charge your phone. Next, we have sound, aka acoustic energy. Think acoustic guitars. Sitting all by itself, an acoustic guitar is not going to make any noise. However, when you pluck a string on that acoustic guitar, you create a vibration in the string, which releases a wave, and that reaches your ear as sound. So a moving wave with traveling sound energy. Thermal energy, heat energy. We talked about this with conduction, convection, and radiation. And again, this calls for the motion of molecules. Now this could either be friction, rubbing molecules past each other to warm your hands, or this could be molecules that are vibrating. And molecules in motion release heat energy and some thermal energy. Chemical energy. This is kind of the unsung hero of the energy world because chemical energy is stored energy. There's a key word in there, stored, meaning it's not obvious that the object has the ability to do work. Take your food, for example. Food doesn't appear to be doing very much, but all food has calories. Calories is your stored energy. So as soon as your body starts to digest those calories with heat, then you are releasing the energy that was stored up. Same idea with batteries. Batteries sitting on a store shelf, pretty unimpressive, but there's a lot of stored chemical energy inside, and it is released when you connect the battery into a toy, a video game controller. And gasoline at a fuel pump. Gasoline is not doing very much stored at the gas station. However, when you put it into your car engine and you burn the fuel, you are releasing the stored chemical energy. And finally, nuclear energy. This is where we are pushing to transfer our burning of fossil fuels to make electricity into more of a nuclear set. When we rip apart the nuclei, or if we force two nuclei together, neither situation makes the nucleus very happy, but that releases a lot of energy. So the sun, the atomic bomb, these are all examples of nuclear energy. Okay, all right. So what we want to do is we want to use an example of something that's been happening a lot at my house recently, watching a lot of Looney Tunes, and we want to see if we can pick out the different forms of energy. So let's take a look here. Okay, so as the Roadrunner is racing down, he is in motion. The form of energy that describes motion is mechanical energy. So I have already identified one form of energy that goes with this clip, but it would be very rare for any system or any object to have just one form of energy at work. So I want to look for as many as could apply. I also know that if he's running this fast, his feet have eventually touched the ground at some point, which means his feet have been using the ground for some traction, making some friction, and that's going to cause some thermal energy, some heat energy, which I can also see with some little puffs of smoke coming out behind him. He's been running around and I could hear that process, which means he had some acoustic energy there. And I can't see it, but I can assume if he's able to travel this fast that he was using some stored chemical energy from some of that bird seed that he finds. So what I'm going to do is when you're done with this video, you're going to open up this link in Google Classroom, and it's your Looney Tunes energy scenes. So I've done the first scene section for you. We identified 3 to 4 different forms of energy from what we watched, and here's the link provided for you. You are going to continue to watch the video and pause when you've seen a new section of the scene and describe the forms of energy that are available. All right, now let's go ahead and get back to it here. We've talked about our different forms of energy, but now let's focus on the 2 main umbrella terms of energy. Each one of those forms could either be kinetic energy or potential energy. And I know you've heard those 2 forms before, so let's just break the cobwebs here. Kinetic energy is energy in motion. It's obvious that it's doing work, but the amount of kinetic energy that an object has is directly related to its mass. Mass is the amount of molecules that are in a certain space for the object. And we have a little saying, the bigger they are, the harder they fall. Well, it is true. The more mass an object has, the more energy it's going to have as it's put into motion. And this directly relates to what we call potential energy. Now, potential energy is kind of like the opposite of kinetic energy because potential energy is stored. It's not obvious that the object is doing work, but this stored energy allows us to do work in the future. And we can get potential energy in one of two ways. The first is from gravitational potential energy. There's a root word in there, gravity. Well, the higher an object is placed, the more potential it has to fall from that height. So the higher it is, the greater a distance it has to fall, which means the more work it can do as it falls and as it lands. So if you look at this situation, if I were to place a bowling ball on the top step of my staircase, would it have more potential to fall and do work than a bowling ball placed on the floor at the bottom of my staircase? Well, yes. The bowling ball at the very top of the staircase, when it rolls down, it's going to do a lot of work or a lot of damage to each of the stairs on the way down because it was placed at a great height. The bowling ball on the floor, does it still have stored energy? Well, of course it does. But when that bowling ball already on the floor is set into motion, it will not do as much work as the bowling ball that was at a greater height. So in other words, the more height we provide an object with, the greater energy it will have as it travels. Now, we also have elastic potential energy. Elastic, stretch. You have been experimenting with elastic potential energy since your first encounter with the rubber band. Now, if I stretch the rubber band, all I want to do is see how high it will fly. So in order to make it fly as high as it goes, what do? Well, we stretch it as far as it will go, and then we let it fly. But as much as we want to see how high this will go, all the rubber band wants to do is go back to its original shape. So the more stretch that I give an object, the more potential it has to snap back to its original shape. The more potential it has to do work with the greater amount of stretch. So what I'd like you to do now is you're going to go ahead and pause the video and you're going to go back to your Google Doc and you have an assignment called the Forms of Energy Sort. So what you have at the top, you have all of our forms of energy: mechanical, acoustic, light, chemical, nuclear, electrical, and thermal. And we have our two main categories of energy: kinetic energy, which is energy of motion, and potential energy, which is stored energy. So I need to sort each one of my forms of energy into its correct category. So for example, first form on my list was mechanical energy. Well, mechanical energy means something is in motion. Kinetic energy is the energy of motion. So I'm going to enter mechanical as my form, and I am going to define or describe mechanical energy. And you can, of course, use your PowerPoint notes to help you with that. So you need to sort each form of energy into whether it's kinetic or potential. All right, guys, I'm really glad that we are getting started on some new material and a new unit, and I will see you online tomorrow after you have tried some of this practice. Give it a shot. See ya.